All right, so for today, I've already done class grades and exams and stuff. Today, I want to do these two sections right here. 5.1, 5.2, 5.3. There is a chat question. That's all right. If at the very least, I know I recommended against this, but if at the least you have a cell phone that can do it, maybe your cell phone might be able to access it. Otherwise, don't worry. I'm recording it anyway. You can watch it later. Yeah. Okay, so for today, I want to do 5.1, 5.2, 5.3. We are starting brand new topics today, which is one of the reasons why it was great that I stopped where I did last week. I did not want to push for 5.1. I actually wanted to sort of keep it self-enclosed. But today we start actual trigonometry. So before we were doing some stuff with math analysis, looking at stuff, looking at math sort of notation-wise, analyzing certain things that we know to be true, right? But we never did anything with angles. That's what we start today, okay? And just really quick, so let me jump over to 5.2. So we're going to cover this section today too, but I'm pretty sure some of you guys have just printed out 5.1, 5.2, and 5.3. What I want people to print out is this. So I'm going to make you guys do this thing right here. This thing right here. I'm going to make you guys fill this out for your lecture questions, right? But what I want people to do is I uploaded onto your into your files for the class. I uploaded a big blank one of those. Okay, and the reason why is because we're going to use this repeatedly from here on out. So if you guys wouldn't mind going ahead and printing out one of these as well, which is just a blank round one. It's called the unit circle. I think I put it already in the chapter 5 stuff. If not, stop me and I'll go ahead and upload it again. So this right here, we're going to be using a lot, like a lot. Okay. All right. 5.1. 5.1. Okay. So today we start trig. This is going to be a so for the next maybe 3-4 chapters, we're going to be doing a fair amount of stuff that has angles. So there's going to be a fair amount of geometry involved, a fair amount of the stuff that we did previously involved, and a whole bunch of this stuff called the unit circle. So we'll pick this stuff up as we move along. So this deals with just how to read an angle and how, just how to read an angle and how it works, at least in the context that we need it, okay? So first of all, what we're going to start with is drawing and labeling of angles. So whenever we have an angle, right, we have this angle right here. It has a vertex, right, and it has 2 rays that goes outward like this, right? Okay, and the way that we denote it is like that, DEF, where see that vertex point that's right there? That's that middle. It's the middle letter there, okay? Depending on how we really want to call an angle, right? we usually have one of these variables to use for them, okay? They're all Greek letters. We have these 5 variables, so it's either theta, phi, alpha, beta, gamma, or we can just plainly, the one that you'll see a lot, we sometimes just call it x. And when we refer to an angle, we refer to sort of like this distance that's right here between those two rays, okay? What we will be using a lot are angles that are in what's called standard position. And standard position is essentially like we have it over here. So the standard position is the vertex is at the origin, right? And the initial side, this side right here, is always along the y-axis. Or sorry, x-axis. Okay, so just as before, if you guys need me to repeat something, let me know. Okay, and then we have okay. No meeting password. Meeting password for the class. Meeting password for the class. There is no meeting password for the class. Michelle. Cannot open the Zoom. So Michelle, if you can tell Mohammed to restart his computer, maybe that might do it. No guarantee, but I think that might. He was on here earlier. Yeah, he must have gotten dropped somehow. I had the same issue as using the link we were first given. Does anybody log in through the Confer Zoom? Yeah, through Canvas. Okay. Really? Edlin, do they can you get to the Confer Zoom on the Canvas webpage? Or does it not even work that way? Huh. Okay. Yeah, I think that's how should be the password. That's how it usually supposed to work. I wonder. So did you guys hear over the weekend that Zoom was being sued for Zoom was being sued because of privacy concerns. So I wonder if there was going to be a bunch of changes made from Zoom that we now have to get accustomed to. Awesome. Okay. Let's see how many people we got now. Okay. So I'm going to keep going. Again, I have my chat box open. So if you guys need to ask me questions, keep going. Okay. So we have, where was I? Oh, there we go. So there's this thing called standard position for an angle, right? Where the vertex is at the origin and then the initial side is on the x-axis. So what does that mean? It means exactly what it is here, right? So there's my vertex. It is at the origin, and that initial side, right, is along that x-axis, right? And the last bit is what's called this terminal side, right? The terminal side is basically where the angle ends, right? So in this case, it's right there, okay? Yeah, okay, so we have, so what I want to do is a couple of examples of positive and negative angles. So let me actually go back up here. An angle that has its initial side right here, right, and goes this way, that's called a positive angle, right? And same thing, starts here and goes the opposite direction, is called the negative. So that means counterclockwise, right, is positive and clockwise is negative. Okay, but the idea that you guys all have for it is about the same. Okay, so for example, we do, yeah, let me do the first row here, and then I'm gonna have you guys try some more later, and try the bottom ones. So 90 degrees, right, is, so I'm gonna draw my, right? Here's my origin, here's my initial side. I'm gonna use red. So here's my initial side, right? 90 degrees is straight up. Does that make sense? So my angle went, actually, let me get rid of that square. My angle went that way, a positive amount, right? So now same thing with 270 degrees. So my initial side is right here, and I have to go around this way to here. So this angle right here, from here to here, is the 270 degrees that I need. Let me change this to 90 degrees, right? And notice the direction I went. I went counterclockwise, meaning positive, right? So now, these two. So here's my axis, right? Here's my initial side. Now I need to go negative 90 degrees, right? So instead of going counterclockwise, now I need to go clockwise. So that ends up being down here. So if I go here, that's negative 90 degrees. Notice what happened, right? I went in the opposite direction, hence the reason I went for the negative, right? And then same thing for this one. So here's my initial side, right? And I need to go negative 180 degrees. So again, I need to go clockwise, right? I need to go clockwise 180 degrees, and that's halfway across. So this is my negative 180 degrees. Got it? Okay, so what I want to do now is I want to break you guys up into smaller groups. If I can ever figure out how to do it. There we go, breakout rooms. And I'll do this. 1, 2. I thought I had done this for these. So there's my 4. It's going to be 1, 2, 3, and 4. Depending on what group you're in, go ahead, try that one. See if you guys can get an answer for it, okay? And I will see you guys in a bit. No, I'm letting him do some work. Can you make breakfast right now? No. Are you going to make breakfast or lunch? Breakfast. No, lunch. Okay, what's?
It's not glitchy for you?
Huh?
Assume it's not glitchy.
No, not entirely. The other students are doing worse though. They're they can't log on. I went from 20 students that I had last 2 weeks ago down to 10. I only have 10 students in the project. You can argue that that's the Monday after spring break. But no, it's becoming a bit too serious for people. And I've already had a slew of drops. All right. So is it work? Everything that people did over spring break? Just work, 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 work.
How many Pokemon cards do you have?
So many. You're essential, Brittany. Oh my God. Well, yeah, okay. I guess so. There's some random businesses that they've considered essential that I don't think should be. Like I think I recall where is this somewhere in Michigan, um somewhere in Michigan, I think of like a video game store, so like GameStop, um anywhere that sells video games, basically they were considered essential. I was like, how? But okay, whatever. Oh, and then the one that sort of is really weird, like places of worship are considered essential businesses, but and some of them are forcing their patrons to go to mass or go to service when that's what makes everything worse. So I don't know. Yeah, right. Yeah. All right. Let's see. Sharing the right screen. Yep. Okay. What'd you guys get for 180?
It's gonna go like straight across, and then it's gonna be counterclockwise.
Right. So same idea, right? You start here. This is the initial side, right? And it's going to go straight across that way, right? And you needed to go counterclockwise. Done. What about for 360? What do you guys got? Wow, you guys are really, really quiet today. Much more quiet than usual. You guys tend to be my noisy class.
Okay, for that one,
Yeah,
the two the two arrows on the same line, right?
exactly. So your initial side, right,
Yeah.
going to be sort of exactly on top of the terminal side. And the way that you argue that is you go one full rotation. That's how you got that, right?
Yeah.
Yep. There it is. This is the positive 180, 360. So now, negative 270. How do you guys do that one?
It looks like the first one that we did, the 90-degree one, but instead of going counterclockwise, it's going clockwise all the way
Right.
around.
Right. So we'll get into this a little later. This actually has some pretty good meaning here. So here we needed to go into the negative direction, right? So we need to go clockwise. And in that case, we go negative 270 and we end up looking at something that looks like the first one, but it's not. It's actually, we went the opposite direction. And what about the last one?
The double arrow on the x-axis facing the, I guess, right direction
Right?
and going clockwise.
And we need to go clockwise this time, right? So we need to go, right?
Yep.
This is going to be the negative 360, right? So notice that the similarity between these two, right? They're exactly the same drawing, except we went in the wrong or in opposite directions, right? Okay. Okay. So there's going to be a bunch of angles that we are going to be referencing repeatedly. Okay. And I've drawn them out here. We're going to go back and forth because we do need to convert some values to other values. And I'll show you guys how to do those. So the first ones that I want to get to are the ones that go here, 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 and here. So we have one drawn in, right? 90 degrees. The one way over here is 180 degrees. And the one down here, as you guys have probably seen from the previous example, 270 degrees. Cool. Okay, these are sort of like the baseline ones. Okay, just your four corners. Okay, your north, south, east, and west. There's four more that I want to get into. It's the ones that are in between. Okay, all four of those are halfway between the four corner ones that we just did, right? They're exactly smack dab in the middle, which makes this one 45 degrees, right? When you add the same thing over here, it is, so we need something between 90 and 180. That's 135 degrees. Okay. We need something for this one. We need something between 180 and 270. That is, whoa, that is 225 degrees. Actually, write it right. 225 degrees. And then the last one way over here is going to be 315 degrees. Make sure I did my math right. 30, 45. Yep. Okay. And notice how we figured those out. So this angle right here is 45 degrees, right? Just how this angle right here is 45 degrees, 45 degrees, and 45 degrees. Okay. Coolio. Okay. The next, how many is it? 1, 2, 4. The next 8 points, or the next 8 angles we have are the green ones. And these green ones have sort of the same getup that the other ones did. The only difference is the angle measure. So this is going to be 30 degrees. Got it? Okay. And just the same way as this is 30 degrees, this is also 30 degrees, right? So that makes this 60 degrees. And we start going around by chat room. 360 in this. So I'll get to that in a second. So I go 30 degrees. And then I go another 30, that's 60. I go another 30, that's 90. You guys see how this works out now, right? So then my next one would be 120, 150, 180. You guys see how those came out? 210, 240, 270, 300, and then 330 over here. Got it? So a question came up and that said, where would 360 be? So 360 is technically the same thing that we were doing before. So here is our origin. 360 is one whole spin around, right? So that means that our 0 degrees is also our 360 degrees. The only difference is 0 degrees means we stayed here, right? And 360 degrees meant we took one whole spin around in the positive direction. Okay, so let me move down to here. So we know a bunch of the angles, okay? There is what's called a radian, okay? And the radian is what we define. Let me see. What the heck is a radian? It is how we attempt to measure the circumference of a circle based on the radius of a circle. Okay, so that's why it has the word radians in it. It's based off of the radius. Okay, so this is extra information. Yeah. That's it, extra information. So pi is sort of like the circumference of all the circles divided by its corresponding radiuses. Okay, so basically saying how many radiuses, so let me take the circle that's below, right? My radius for a circle is from here all the way out, from here all the way out to the edge. Okay, how many of these radiuses, how many of these lengths can I put around the edge? Okay, and that number tends to be something very nice, and that's the number that we call pi. Okay, so what a radian is, right, is the amount, how many radians I can stick along, how many radiuses I can stick along the circumference of a circle. Okay, and it's a ratio, like how many times can I put a radius of a circle along blah, blah. How many times can I put a radius of a circle around the circumference? And that's where we get our 6.28 or 3.14 for, 6.28 for one radius around, or one complete revolution around, or 3.14 for half a revolution around. So if you grab a radius, if you grab this radius right here and stick that 1, 2, 3, and some, you can technically grab this one radius and stick that around 1, 2, 3 times and a little bit. And this is your 0.14159. So pi is essentially the number of times you can grab a radius and stick it around a circumference. Okay. This number tends to be a bit more useful for mathematicians because it gives a measure of a circle, of a part of a circle, based on a measurement from itself. Okay, instead of sort of 90 degrees, 0 degrees, we don't have any reference point for them, right? If we start talking in number of radians, we know that it is part of that the definition or the number that we're going to get is from the radius of a circle. Okay, hence the reason why we have radiuses and radians. Okay, there are different ways to there's only two ways actually to measure angles. One we've already seen, It is just plain old degrees, which is fine, right? And then the other one is the radians. And that's the thing that we're going to do now. And the way that you convert between the two is right there. Okay. The better way, I think, the way that I've learned how to do it is if you have degrees, right? You multiply. Whoa, that's a horrible arrow. You multiply times. My pen's glitching. Times pi over 180. And if you, actually, let me rewrite that better. Degree to radians. You multiply pi over 180 and then radians to degrees. You times 180 divided by pi. Depending on which one you want, you have to do one of these two operations, okay? So what I want to do is I'm going to use these angles right here. I'm going to try to fill these out like it says right here, and I want to fill them out in radians, okay? So we know that this is a 30, 60, 90, and 45 degrees, okay? So I'm going to go ahead and do 30 degrees first. So according to, I'm actually going to give this a nice color. Okay. If I need to go from degrees to radians, I need to multiply by pi over 180. Which is 30 pi over 180. And now I need to reduce. Okay. And if you reduce this right, you get pi over 6. So this is also equivalent to pi over 6. Okay. Same thing happens with 45 degrees multiplied by pi over 180. So 45 pi divided by 180. And that gets you pi over 4. So this is also equivalent to pi over 4. So 60 degrees, let's go ahead and do the conversion first. So 60 times pi over, pi over 180. 60 pi over 180. And this reduces to pi over 3. And let me go ahead and just do 90 degrees now that we're here. Ninety pi over 180 pi over 2. So this is equal to pi over 2. So there we are. We have our, okay, the one that I want to point out really quick. Well, the two that I want to point out really quick. Well, actually, let me just go ahead and point out this whole thing, huh? What I want people to notice is this. This right here, that's 45 degrees. So this is pi over 4, right? There's another length right here. This is also 45 degrees, or pi over 4, right? And it turns out all of these angles are summative. So you can sum up angles to get the new angle. So this angle right here from sort of this initial end to this terminal end right here, right? We know that's 90 degrees, right? Which should be pi over 2, right? And it turns out everything still works out the same way, because if we do pi over 4 plus another pi over 4, so it's pi over 4 plus another pi over 4, 2 pi over 4, and this reduces to pi over 2, which is exactly what it's supposed to be. All is right with the world. Does that make sense? Okay. And then likewise, this is pi over 3. Or sorry, this is pi over 6, right? So 30 degrees. This is also another 30 degrees between these two right here, right? And then this right here is also another 30 degrees. So we have this going on, right? We have 30 degrees, 60 degrees, 90 degrees, right? So then let's go ahead, add them up using your the pi over 3, the radian measures, basically, right? So, and if we have pi over 6 plus, we know that this is pi over 6. We're adding another pi over 6 to pi over 6, and that reduces to pi over 3, which is exactly what we were supposed to get when we added two 30 degrees together, right? And then lastly, right, we have pi over 3, and if we add another pi over 6 measure, radian measure, right, then we get pi over 3 plus pi over 6. That's going to be 3 pi over 6, which is pi over 2, which is what we were supposed to get to begin with anyway. Got it? Stop me if you need me. Why are we using ratios instead of real numbers? So like I said, the idea behind the number pi, let me grab all of this, because I do want all this. I'm gonna move it. I just learned how to do this, and it's awesome. A little bit over here. Okay. It's all based off of the definition of pi. Okay. I do understand that people want to maybe sort of default to using angles, and that's okay. The reason why we have pi is because it refers back to a portion of the circle. So sort of making the idea of what we're referring to sort of self-enclosed in the geometric shape that we're talking about. If we do 30, 60, 90, 120, 55, 85 degrees, that doesn't give us, it gives us information, right? But it gives us an arbitrary point of information, right? On the other hand, pi gives us the number of times, or how many times we need to stick a radius of a circle together to get its circumference. So it's basically sort of referring back to the shape itself. So pi refers itself to the shape, and degrees don't refer to anything. It just refers to like a distance. And in math, at least, the pi notation or the pi symbol is much more useful than sort of degree measurements. That answers your question, sort of. It's one of those. I mean, I haven't been able to use this line very much in this class, but it's one of those lines where if you really, 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 really want to know, go get a math degree. You have any exam price? Michelle, I don't understand your question. Do we have an exam? I'm going to have it. I want to have it Wednesday of next week. It'll be covering chapters 4 and 5. Is that what you needed? You have an exact price? I don't understand your exact price. We shouldn't be paying anything for the class anymore. Okay. Let me keep going. Michelle, hold your question until let me see. Do we have any exact price? Oh, well, it's not a price. I think you want to say a value. Do we have an exact value? uh, so pi is a never-ending number. And so pi, the number itself, is 3.14159 2736 ... I can't remember the rest, but it never ends. It is what's called a transcendental number. There is it's a decimal number that never ends. Let me just put it that way. Okay. Okay. So you guys see how this thing worked out here, right? Right there. Okay. Turns out we can use that to fill in the rest. So we know that from here to here, actually, let me do the 45 degrees. From here to here, that's pi over 4, 2 pi over 4. Right here to here, this would be our 3 pi over 4, right? And this would be 4 pi over 4. And this reduces to pi. So half a revolution around is pi. Okay, and we now keep going. So from here to here, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, right? 7 pi over 4, and then we take our last lap around. This is 8 pi over 4, which is equivalent to 2 pi. So you can simplify if you need to. Got it? Okay. We're going to do the same thing with the pi over 6s. 1, 2, 3. So we know from here to here, so this is pi over 6 up to here. 2 pi over 6, which reduces to pi over 3. 3 pi over 6. Another 30 degrees here is 4 pi over 6. 5 pi over 6. So from here to here, it's another pi over 6, another pi over 6, another pi over 6, which is how it's supposed to work out, right? So this actually reduces to pi as well again. 7 pi over 6, 8 pi over 6. This is 9 pi over 6, which if you reduce it, gets you 3 pi over 2. So notice how no matter which way you get to the common ones, they still work out. Okay. The one right here, I know this is going to be a little tight, but I'll put it in here. That's 10 pi over 6. 11 pi over 6, and then finally 12 pi over 6 brings us right back to 2 pi. Okay. What I do want to do is we've done a bunch of, so what we did up here was we converted degrees into radians. I now want to go from radians backwards toward degrees. And the example I'm going to use is that one, 7 pi over 4. So if we grab 7 pi, whoa, and I want to convert it, so this is my radian measures, I want to convert it to degrees. Using our little thing that's up there, we need to multiply it by 180 divided by pi, okay? And the way that that happens is 7 pi over 4, 7 pi times 180. Let me calculator out. Is 1260 pi over 4 pi. Those cancel, and you get left with 320 degrees. No, sorry, 315. Which, if we check up here, is exactly what we should have gotten. Okay. That was a lot. So what I want people to do now is I want to give everybody some time to practice with this stuff. So I'm going to split you guys up with in 4 more groups. And I want you guys to try the conversions that are there. So your group number gives you the group that you're supposed, or the problem that you're going to be trying. It's 2 of them, right? You're going to be converting radians to degrees and then degrees to radians, okay? Everybody gets to practice 1 of each, okay? So I'm going to break you guys out. Everybody's so quiet. How many people are still in bed? Thankfully, I'm not, but I wish I was. Me, Madison. I am super tired though, even though we just had spring break. Let's see. Mashal, I think I saw earlier and you just reminded me of something. Meeting password. Let me see. Okay. Let me close. Okay. Mashal, I'm trying to send him an email, see what happens. Huh. For a password. Oh, there's a lot of people. No wonder.
It happened to me when I tried I think it's for the people who do when the link you sent out, if they click on that, it's gonna ask them for a password. But if you go to Zoom and join through there, it's not gonna ask you for one.
Huh.
Because I was having
Okay.
trouble with that too until I called Molly and she explained to me how to do it.
Okay. Yeah. Okay.
So just
I
don't
need to.
use the link.
Yeah. Don't use the link. Use like Confer Zoom.
Yeah.
Okay. Good that some of you guys figured that out. I need to send out an email right now. How about this? Before we try these out, go take a break so I can send out an email to everybody that's stuck in the interwebs trying to log on. So we're on break for now. All right. So it seems like we lost people. All right. All right. How's everybody doing? No, this is not the best stuff to come back from spring break to, but
There's only 7 of us here. Is that including you?
that is including me.
Oh God.
Yeah. That's nothing. I got so I guess the college has allowed the drop deadline to extend a little farther.
Yeah.
I got the first slew of a couple drops from this class.
Oh really?
Yeah.
Damn.
Yeah. How many dropped? I think I saw in. Now this is the emails that I got. I got like a good 70. So I think it was a good 2 or 3 dropped from this class.
I mean, I wouldn't blame them.
Yeah, that's what I mean,
But
and I've gotten emails from a lot of people saying like, hey, I'm really worried about how I'm doing in the class. I don't know how I'm gonna do it with online and this and that. And I'm like, dude, I don't blame you. I would be worrying about the same thing if I signed up for an actual like in-person class and uh, that turned into you know an online class. I would be very worried as well. Um, and I mean, like I said before, right? You guys are now worrying about stuff that you didn't have to worry about before.
yeah, it's like now school is like with all this going on, it's like the least of our worries right now.
Mm-hmm.
It's like,
So, yeah, and I've told people like, I get it if you can't do it. I get it if you need to drop something. I mean, it's not going to be the first time, and this sets everybody back.
yeah.
Everybody. So
The only reason I haven't dropped because I don't want another W on my transcript.
yeah, I think that's everybody's worry. I don't even know if they'll put the W on there.
I think it said that they're not going to put the W.
Yeah,
For anything, for any classes?
for any classes. I think there's still a deadline for that to happen, but I think for now, I think I read that if you withdraw now, you don't get the W.
Shit, that makes everything different now.
Yeah, I know. I mean, I hope you guys don't, but like I
No,
said before, right?
this class I absolutely can't drop because I'm trying to be out in 2 years.
Yeah, but like I said to everybody, right? You guys do you.
Yeah. I'm so tempted, but I know I shouldn't be I should not
Yeah.
not drop any classes. I'm
Yeah,
just gonna push through. There's only like what next month left, and we're done. I just need
and
to
you're
push.
done. Yeah. So, um, I mean, I'm pretty sure. Hopefully, all the other instructors are making it a little nicer for people to do well in the class,
Yeah.
considering the fact that everybody's now going on to this funky format. So,
I'm so behind on everything, and like it's just I tried to open up the chapter 4 like assignments that
yeah.
were due, and it says all of them were closed.
So I think I fixed that Saturday night because I got emails from people.
Oh, okay. So they're up again.
Try it.
Okay.
Try it. If it works, great. If not, let me know. I'll see what I can do.
Okay.
I might have to turn a couple of them into extra credit or something. I don't know. We'll figure it out.
Okay.
How can we
Oh,
reach
damn, I have
you
to make
during
this-
office hours? So office hours. The question came up for office hours. Let me go through that really quick one more time. So let's go.
Damn, I have to use late passes for all of these.
I can hand them out. I can hand out rate passes. So office hours. So I have this online office hours link on your home pages for your course, for the pre-cal course. I have this link right here. So you click here, it'll take you to a Zoom office hour. Okay. Today, do I have office hours today? I think I do. So let me actually expand this really quick. So I'm going to try to keep the schedule the same as usual. So I have office hours today from 2 to 3 p.m. So from 2 to 3, if you go to that link and you click on it, that's where you'll be able to see me. That's where we'll be able to talk. Okay. That's the other question that now that you brought this up. A couple of you guys have been sending me emails since I put the exam grades in. Now you guys can't see your test and how well you did. So what I'll be able to do during office hours is if you want to see your own grade and if you want to see what you did wrong, I can put it up on. I don't have anything to scan it to send it to you guys, but I do have something. So I'm on my tablet, so I can show you guys what you did wrong, like sort of like in paper. So I'll hold up the paper to the camera. Does that make sense?
The highest grade on the test was?
The highest grade on the test was a 95.
Damn.
Yeah. The highest grade was a 95.
So do you think we're gonna be able to get more late passes to do the chapter 4 things?
Oh hell yeah! I can hand those out like hotcakes, man.
Cool, because I'm gonna need those.
Yeah, and dang it, I didn't put up any of the stuff for chapter 5 yet, did I?
No, it's not a.
No. Okay, so I'll put up the stuff for chapter 5, and like I said, I'm not gonna care about too much about the due dates for them.
Okay.
Just get them done. I'll throw out late passes like hotcakes if needed. So
Okay.
I'll throw them out like candy,
I'm
just so
gonna.
you guys can do them.
Yeah.
Video assignments for section 4 were all still closed. Still, I thought I figured. Does everything else work, Miguel? Like the actual assignments? Okay, so it's just the video assignments that don't work. Okay. Okay. Maybe I'll just make those extra credit
For section 4.
for section 4. Yeah.
The video assignments or the the regular assignments
The,
too.
the regular assignments I'll keep the same, but the video assignments I think I'll make extra credit.
Okay.
I forgot to put up the stuff for chapter 5 too. Oh my god. And last night I was fixing up the last couple things for my lectures for like the next 2-3 weeks. I was like, all right, I feel good. Everything's done. And now I'm realizing, crap, I didn't. Huh?
Just when you think you're like on top of everything.
Yeah, just when I thought I thought I was on top of everything, ready to go, good to come back. I come back and find these things that I forget to put up. I forget to put up um, the lecture notes. I forget to put up your guys' homework. Yeah. Well. Oh my god, so annoying. All right, back to this stuff. 72 degrees to radians. What do we multiply by?
Pi over 180.
Right, so 72 times pi over 180, right? So this is going to be 72 pi over 180. Does that reduce?
It was like 2.5 pi.
Okay. So we can, yes, you're right. We can, let me go through the steps for reducing, right? So first reduction is I can divide both the top and divide them by 2, right?
Mm-hmm.
So that's going to be 36 pi over 90. I'm going to reduce it one more time. And now I can divide it by, what is it, 9?
Oh, yeah.
So it's going to be 4 pi over 10.
Reduce that by 2.
2 pi over 5.
Okay, I did that wrong. I just divided 180 by 72.
Huh?
2 pi. Nothing.
Okay.
2 pi over.
And there we go. So the equivalent radian measure for 72 degrees is 2 pi over 5. Six pi over 15. Which one did you get for that one?
Which one was that one?
Somebody said divided by 3. Oh, no. Yeah. Miguel, you could have reduced it one more time. Okay, let's go ahead. I forgot to, I'll do these really quick, just so that everybody gets some practice. So if I want to go from radians to degrees, what do I do?
You multiply it by 180 pi.
Right, so then 5 pi over 18 times 180 over pi. 5 times 180. So it's going to be 900 pi over 18 pi. Now, if you did it this way and you reduced, that's perfectly fine, right? I like to reduce from right over here automatically. Okay, so just how you remember how to reduce it back in kindergarten, right? So this is 18. So if I cancel these, I get left with 1 and 10, right? And then pi and pi cancel. And that leaves you with 50 degrees. Same thing if we cancel here, right? The pi's cancel out. 900 over 18, which is equivalent to 50 degrees. So either which way you want to do it is fine. Still asking for a password. Okay, so let me see. So everybody's still having a problem with oh my goodness. Okay. I'm not. Okay. I'm going to send out another email. Okay. I wonder if we're going to blow up with people right now because there was like a good 7, 8 emails saying that the password, that they were asking for passwords. Oh no. So the way that you guys logged on has been through the Confer Zoom, right? So you logged in through excuse me.
That's the way that works for me.
Huh?
Through Confer Zoom, that's the way that worked. It didn't ask for a
Yeah.
password
So
or
you went through your Canvas page, right?
yeah. I clicked on the class and then went on Confer Zoom.
Yeah. Left panel options. Yeah. Okay. Huh. I guess some people. Well, we'll see what happens when people get on right now. Miguel, it wasn't an oops. You just stopped a little early. That's it. But you got the same thing. All right. While other people get here, 1080 to radians. What do I multiply it by?
Or pi over 180.
Right. So 1080 pi over 180. So I can automatically right? And I think 108. Yep. 6 pi. And it makes sense, right? So 6 pi means how many rotations around the circle?
How many rotations?
Yeah. So 2 pi, right? Let me get rid of this. 2 pi was one entire rotation around, right?
Mm-hmm.
How many rotations is 6 pi?
That's 3.
That's 3 rotations, right? And then if you take a look into it, right? So if you grab 1080 divided by the 360 for one rotation, right? That's the same as 3 rotations. Got it?
Got it.
Okay. Let me see. 3 rotations. Yep. Okay. Last one. Negative 2 pi over 15. So just how we were doing positives, you can do the negatives the same way. So then negative 2 pi over 15. What do I multiply it by to get to degrees?
Uh, 180 over pi.
right? So then I'm going to cancel from here, right? So the pi's cancel. So it's going to be negative 360 over 15. And this is equivalent to 24 degrees. We good?
Good.
Okay. Okay. Coterminal angles. Okay. We're getting down into the bits where so we're going to get into this thing called the unit circle. The unit circle has sort of like predefined values on them, right? And those values tend to be very nice because they have all the values that we would possibly need sort of at a close by. Does that make sense? We're only going to be using basically this thing right here over and over and over and over again, okay? The only sort of difference is like you guys saw for this example right here, right? For 1080 to radian measures, right? That's equivalent to spinning around the circle 3 times and then stopping right back at the beginning, right? Turns out we can do that with any one of the angle measures, okay? And that is called finding coterminal angles. So 2 angles are coterminal when they have the same terminal angle. Or sorry, terminal side. So long as this is the same for any 2 angles, they are called coterminal. Got it? So
Repeat that. I'm sorry.
yeah, so the two angles are called coterminal if their coterminal sides match up. And that's the reason why it's so useful to have later when we have our unit circle, when we have these as references, it'll be so much easier to reference this over and over again than to find values for stuff for every single angle outside of what's not on the unit circle. Okay, so let me give you guys a couple of examples here for A, B, and C, right? So for A, right, find a coterminal angle of 800 degrees, right? So we know what that looks like, right? So if we go 1 around, right, that's 360. Second time around, that is 720, right? And now we need to get to 80 degrees, right? Or sorry, 800 degrees. So if we go up another 80, right?
Mm-hmm.
We have an angle that is coterminal to 800, right? So the coterminal angle here would be that 80 degrees.
Oh, okay.
Does that make sense? So let me actually. Does that make sense with people? Negative 280 would as well. Uh-huh.
So for B, since we know like it's gonna be 80 for 800, will we just add the 70 to the 80 and then that'll be our coterminal angle?
Exactly. So then I'll do it this way. 1, 2 around, right? And then we need to go, we know if we go from A, if we go another 80, we get to 800, right? And then we have to go another 70. So that ends up being, so 2 around is 720, plus another 150 degrees. Actually go over here. So then $150 would also be coterminal with 870. Got it?
Yep. So
So basically, you eliminate the number of times you go around. And you just look at where you end up. So for B, same idea, or sorry, for C, same idea. We are going to, this one is negative 45 degrees, right? So we know that for negative angles, right, we go down. Now, a coterminal angle has to be the positive version of it, right? So the very first time that that happens, right, if we go positive, start here, go all the way around, what angle is that?
wait, what was the question?
For a coterminal angle for negative 45 degrees, we need the first positive angle that is coterminal. So what is this angle going to be right here?
We did 360 minus 45, right?
Exactly.
Would be 315.
315 degrees. We're done. Okay. 2 formulas I want to show you guys for today. The first one is the arc length and the other is the area of a sector. So how do we find, do you guys know the formula for the perimeter of a circle or the circumference of a circle?
Uh, pi r squared, or is it pi d? Or no, it's one of those.
You're close. So you guys remember this, right? C 2 pi r for going all the way around,
Oh, okay.
right?
Mm-hmm.
Okay. So it turns out there's a general formula for it. Whoa. It's that one. S is equal to r times theta, where theta is the angle that you want. So what this formula gives you is basically the length of the arc from one angle to the other angle to the other point from the initial side to the terminal side of an arc. Okay? Now, there's a very important thing that you have to realize here, that your angle must be in radians. So, if I give you an angle in degrees, you have to first change it to radians and then plug it in. Make sense? So, 215 degrees, how do I convert that to radians? Multiply it by what?
Pi over 180.
Right. Oh, come on. Three pi over.
That's as low as it'll reduce.
That's as low as it'll reduce. 43 is prime, so you can't reduce it any farther.
Okay.
So now that I do have my angle in radians, right, I can plug it into my arc length. So S is equal to, my radius is 10 times 43 pi over 36.
Wait, how did you get that equation?
Up here.
Okay, so S equals 0.
So then this is going to be 430 pi over 36.
Is that a 10? 10
Huh?
times 43? What,
Yep.
What is the 10?
Where'd the 10 come from?
Yeah.
Internet connection is unstable. Okay. Circle of radius 10.
Oh, radius 10. Okay.
Yep. So the R up here is still a radius.
Okay.
Yeah?
Yeah. That would equal 430. The 10. Okay, okay. Makes sense. Makes sense.
Is equal to that and then that time. So then this is equal to about 37.5245.
And that's
Got it?
degrees, right?
Huh?
That's degrees.
No, that's the length. So,
okay.
I didn't put a unit here. So let's say that this is 10 feet. That would also be feet.
Okay.
Does that make sense? So that got us this length up here. The length of the arc from the two ends. Okay?
Okay.
Okay. Similarly, we have the area of a sector, right? So the area of a circle, this is the one that you just said, pi r squared, right?
Yeah.
Okay. The actual formula for it, this is the general formula for it, is that right there. And the same caveat, your angle has to be in radians. So you have to convert it first if it's not in radians already. Got it? So, automatic lawn sprinkler sprays a distance of 20 feet while rotating 30 degrees. What is the area of the sector of grass that the sprinkler waters? So this equation gets you this area right here. It gives you how much of a pizza pie you have. Got it?
Got it.
Okay, so I'm going to skip through this a little quickly. So the 30 degrees, right? We know that that's pi over 6 because we've already converted it, right? From above.
Oh, yeah.
So all we got to do now, 1/2 times pi, so pi over 6, or times theta, and then times r squared. With our r
R-
being, huh?
Which one is R? The 20 feet?
20 feet, yep. So this is going to be 400 pi over 12.
And then you would just divide 400 by 12?
Yep.
Okay. So say it was rotating at like 60 degrees,
Uh-huh.
then use pi over 3.
Exactly.
Okay.
So notice what this is for, right? So this is the area of a sector, right? So then if we measured it in feet, in this case, right, the area that will cover is a feet squared. You got it?
Yeah.
So the only thing I want to warn you guys about this is this.
The angle must be in radian.
That the angle must be in radians.
And that's the
So
format that looks like pi over 6 or pi over whatever.
exactly, yep.
Okay.
Okay. All right. I know I slowed down a lot for this. I'm going to give you guys maybe a good 20 minutes to try out the lecture questions. It's not that bad. These are actually pretty simple. I'm pretty sure you guys don't even need 10 minutes for them. In the meantime, I'm going to go see what's going on with the other people. So I'll still be online. Ask me questions. Enter meeting password. How are people doing?
On the arc length.
Yeah.
I'm still in the first step.
Hmm.
But two thirds pi. So would we multiply when we get like our radian? We multiply that by the radius. I mean the find the arc length with the radius 10. Yeah, right. We multiply by the radius.
For the example or for the lecture question?
22. Yeah, the lecture question.
Find the arc length. Yeah, so you need the formula for the arc length, which is that very first one.
Okay.
The same thing, right? You need to make sure that your angle is in radians before you do anything.
Okay. 3 times. Six.
One of these days we should have class outside.
Oof. At 9 in the morning.
Huh?
So how would we find the radian for 140 degrees?
Right. So how would you do it? So if you want to convert from degrees to radians, what do you do?
Degrees. Oh, we're just okay, so we're just multiplying by degrees to radians is times pi 180 over 180.
Pi over 180. That's it.
Degrees to radians. Oh, okay. Wait, but I'm confused. Then I get 2 pi over 3. And isn't it supposed to be pi over something?
Yeah. So well, do the multiplication out. I think you're not you didn't finish up the multiplication.
So it'd be 140 times pi over 180, right?
Right.
So I get 140 pi over 180.
Yep. And reduce it.
I got 2/3 when I reduced it.
It shouldn't be 2/3.
Oh, it shouldn't be? Damn,
Yeah.
I did this wrong. Oh, I suck at reducing. Wait, so
what divides the top and the bottom?
2.
Okay. Well, do bigger first.
We can do 10.
Okay.
14 over 18.
Okay. Now, what reduces 14 and what reduces 18?
2.
2.
So then we get 7 over 9.
Done.
Oh, 7 over 9.
Yeah.
7 pi over 9.
Yep.
7 pi over 9. Yeah, okay.
For the arc length, you just put it in that formula, S equals R. Is that omega? Is that what you
Yep.
said?
Theta.
Beta, okay. Why isn't the pi symbol in the final answer? I mean, I get that we get the final answer in inches, but why don't we times the 70 times pi? Like, why is it disappear?
Which one is this for? Is this for
22.
Is this for the area of a sector, right?
Yeah.
No, it should. It should have a pi in there.
No. I know. No, for the arc. Like, so you get S equals 10 times 7 pi over 9, which converts to 70 pi over 9. But then your final answer is like 7.778 inches. But what happens to that pi? It just disappears? Like,
No. Okay, so
is it almost
that's
just like a millimeters, like a when you're converting things? Like, it's just, it doesn't need
no.
to be.
So remember, I'm still sharing the screen, right?
Yeah.
So just let me. Am I still sharing the notes? Yeah. Okay. So pi is a specific decimal number.
Yes.
It is the 3.14159. So when you multiply it through, you're actually multiplying by 3.141592736. So that's why the pi is not there anymore, because you actually
You
used
are
the number
multiplying
itself.
it.
Huh?
You are multiplying it.
Yes, exactly. So the pi is already in there.
So since I got 2.33 for the arc length,
7.33 for the arc length. Yep.
2.33.
Huh?
I got 2.33 for the arc length.
Let me see. Hold on. 7 divided by 9.
I guess so.
I might have done this wrong.
Move to that, and that times, and I think we want to multiply it by 3. 7.3303 is what you're supposed to get for 22.
What?
7.33.
Yep.
How?
7.33. What did you multiply? It would be 7 pi over 9 times 3, right?
Right.
And then that would give you 21 pi over 9, right?
Yep.
And then you just divide 21 by 9, or no?
Yep. And then multiply it by pi.
Oh, you have to multiply it by pi?
Yeah. So pi was
Oh.
that number. What is it? If you use 3.14159, that's a decent approximation.
7 times 10.
Mm.
And then let me see.
Okay, okay. So 21 divided by 9. And then you multiply that by 3.14. What was it? 3.14.
159.
159. You get 7. Okay. Could you repeat the pi just so I can like write it down?
Yeah.
The reference?
So it's a decent approximation for pi is, and I'll write it down here above.
Oh.
Whoa. Pi is 3.1415927. Let me go back to, I think, I'm checking your numbers, Joe. Okay. How's everybody doing?
I'm still trying
You know.
to find the area. I just moved on to the next step, the next ones.
Yeah. Brittany?
Yeah. Can we go over 23?
23. Where is it at? Okay. Did you
So
guys
would
get?
you-
Did you
do
guys? Blah, 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 blah. Did we get at least the angle right? So the equivalent angle. This is also equal to what? So the 140 degrees is equivalent to what radians?
That's
two.
what I was having trouble finding. That's where I had trouble.
Oh, I think you got it before.
7 nines, right? 7 pi over 9.
Right. That's the 7 pi over 9.
That's
Huh?
what that was. Okay.
So now, the area of a sector, right, is 1/2 times theta r squared. Just
Mhm.
plug and chug.
So 1/2 times 7 pi 9 over 9 times 3 squared.
Right. I hear somebody's having breakfast.
My sister.
Wow.
So from there, we would multiply 9 by 7.3303.
Say it again.
So since we know 7 pi over 9, it came out as 7.3303. Would we multiply that by 9?
Yep.
And then that by 1/2?
Yep.
Okay. So 32.986.
For what, the final answer?
I got 11.
You got 11?
Way off.
Well, not exactly 11, but close enough to 11.
10.99555.
Yep, exactly.
What did you multiply?
I took 7 pi over 18 times 9 over 1 because 3 squared. And then you just do 7 pi times 9, which would be 63 pi. You have that 18. And then I did 63 times pi divided by 18.
Wait, where'd you get the 18 from?
18 was the half. You times that across. So you would half times 7 over 9. So you have 7 pi over 18, and then you use the 3 squared. So it'd be 718 times 9 over 1. Does that make sense with the half? Because you just multiply across. Or you could do the whole thing, but I just like to break it up.
So she did this.
I don't know.
Yeah, sorry. It's really hard to explain and not.
Yeah, it's hard to explain when we're all separated. So it's going to be 3 squared over 1. There we go.
Yeah, that's what I did.
And multiplication for fractions is always just straight across on the top and on the bottom.
So that answer then comes to 63 squared over 18, and then 3 times pi.
Yep. So the answer to this one is, I think most of you guys got it. So the 10.995 inches cubed.
Cubed.
Cubed. Is it cold where you guys are at?
Yep.
No?
Yeah.
Oh,
is.
yeah. Oh, squared.
I was gonna say, I was like, why is this one cubed? Freaking out. I was all shit.
Squared. 2. Joe had sent me a message just, and I was like, cubed? I can hear the inflection in his voice from here. Just cubed?
Yeah, that makes sense.
Yeah. Woo! Oh, that's cool, Joe.
If I'm doing my lecture questions, I'm doing it on my iPad and I'm just writing. Can I just like
You should
submit
be able
it?
to. Yeah, you should be able to just submit your lecture questions straight up.
Okay.
I mean, I think what you'd have to do is like grab your lecture questions, save them, and then save them on your device, right? And then upload the file.
Okay.
But that should work. Should be okay. Did anybody get to do like, so I at least have mine, or had mine. I had my so every spring break I have like a list of spring break to do stuff. Did anybody get to do those?
I told
Like
myself I
clean
was
and stuff?
Huh?
Like clean and stuff?
Well, yeah.
I think we've been doing that since quarantine started.
Yeah, I mean, yeah. Like there's always something that I want to do,
Uh-huh.
but I always tell myself, okay, spring break is when it's going to happen. This time I didn't do too many things. I like the big one that I wanted to do was clean my little patio garden area.
Uh-huh.
That was it.
That was the only one you had?
That's really the only one that I had. I mean, my wife and I were gonna go to Utah to the
Oh man.
to the what's this thing called, to the national parks. So we were gonna fly over to Utah, land in Salt Lake, and then rent a car and do like a week's worth of driving
Oh, that'd
to
be so
hit
cool.
all those all of those national parks over there.
Yeah.
Yeah, so we were gonna go to Arches, we were gonna go to Bryce, we were gonna go to the Grand Canyon,
Oh,
we
wow.
were gonna all those places, and then the coronavirus hit.
I know that like stunted everyone's travel plans. Like 2 of my flights got canceled and my girlfriend can't go to Mexico now for her birthday. And it's just like, I was like, let's drive. And she's like, no.
Yeah, no.
You're
no.
safe.
Yeah, I've heard it's not safe to drive down there.
No, really
So,
anywhere.
Yeah.
Plus, I hate
So,
to be the one to like contaminate someone else. You know?
right, exactly. Yeah,
Like, oh, sorry.
yeah.
I got to work on my bus, so that was cool.
Oh, yeah, that's right. How's that going? You said you were on electrical last time.
Oh my God, we're still there.
You're still there?
I'm still there. I finally got Well, it was like trying to figure out what gauge wires I needed. And then it was just like reading all these forums and everybody's like, oh, okay, well, if it's this many amps and this distance, you should get this. And I'm like, honestly, I feel like I should go bigger than what all you guys are suggesting, because it's like, oh, if you don't get large enough, then like this and that can happen. I was like, we don't need a fire. I don't need to explode. Like,
Yeah.
just wait.
And what's worse is if you choose it too, like if you choose it too small, right?
Yeah, you fuck up your batteries and you
Well,
can
no,
melt the cable.
if you choose too small, you risk a fire
Yep.
because that means your cables are going to overheat.
Yep.
But if you choose them too big, then you screw up your battery, right?
Exactly.
Or you won't get the charge to where it needs to go. So you're making your battery drain much faster.
Exactly.
Yeah.
So it's just been like sitting there, and I've read so many different things, and so many people have their like opinions about it. And it's not just like a gauge that's off. We're talking like from 2 gauge to 4/0. And I was like, okay, so what is it?
Mhm.
You know? So tell me what it is.
Right.
That's like a huge jump between sizes.
Yep.
So
And I bet what you want to do, right, is you're probably going to need to have a generator in there somehow, unless you're going to be powering it by the battery or
I
by
got-
the alternator from the bus.
yeah, so I got isolator installed to hook up the starter battery to 2 internal auxiliary batteries that are also going to be charged by solar panels.
Yeah.
So all of that, but the one that needs the most like heavy duty wires, my inverter, so that I can have like AC and DC electrical in there. So I can have outlets, and that one everyone can't seem to agree on. Like the company itself says get 4/0, so I'm like, oh, okay, but they're also talking about it being like so many feet away from the batteries, and I'm like, mine's really only like 3 feet, and they said times it by 2 because you want to do the full circle of the electrical, so it's like 6 feet, which is nothing, which would be like 0 the biggest. So I have no idea. I'm learning a lot.
Yeah. Keep reading.
Keep reading.
Keep reading. I mean, at one point though, you are gonna have to make like a decision and just say, all right, I'm going with this.
Yeah.
Yeah.
It just sucks that wire is so expensive, and the bigger you go, the more expensive it is. It's just like, Jesus Christ.
It's because of the copper. That's why.
Yeah. Like, good thing everything's so close, or I'd be like screwed.
Yeah.
But it's coming along.
Yeah. Okay. All right, you guys ready to move on to 5-2? See how much we can do in 15 minutes?
Yes, please.
No, please. I gotta move on, Miguel. I got to keep going. So, how about that Tiger King?
Oh my God. Me and my sister just started watching it. Awful. And it took like
I'm just saying 2 things, okay? It used to be 1 thing, but now it's 2 things. OJ did it and Carol Baskins did it. That's it.
What? Oh my God. Okay. I was like, wait, who's Carol Baskins? Oh yeah.
Yeah. You haven't gotten there yet, maybe.
No, we're still in the beginning episodes. All I gotta say is that show already took like a way different turn than what I thought it was gonna go. Like so much incest and like incest, but like manipulation, and it's just like, you poor little kids.
Yeah.
Ugh, awful.
And the mullets, my goodness, the mullets.
He's bringing them back.
Yeah. All right. Unit, circle, sine, and cosine functions. So, what this section is going to deal with is the definitions for sine and cosine. These are the biggest things that we will be using in trigonometry. They are sort of what trigonometry sort of lives off of. But first, I want to cover some backbone stuff before we move on. And the background that I want to get to is this theorem right here. So everybody should recognize this theorem. It's the Pythagorean theorem. So suppose you had a right angle, right? Then this squared, this squared plus this squared has got to be equal to this squared. That's simple, okay? So I want to use this on an example. I want to find the missing length because we're going to be doing a fair amount of this. So we want to find that side A. What is that? How would I find that? Oh, you guys are done, huh?
It would be 17 squared minus 8 squared, or it would be the square root of 17 squared minus 8 squared.
Right, so how about I do it from the very get-go? So there's going to be some a squared plus some b squared is equal to c squared, right? My a, we don't know, so we're going to leave it that way. My b, we do know, right? That's the 8 squared. And the c, we do know, 17 squared. So a squared is 17 squared minus 8 squared. So a has to be the square root of 17 squared minus 8 squared. 17 squared is something 289 minus 64. So a is equal to 15. So everybody got the example for how to use the Pythagorean theorem at least? Okay. So finding functions for values of sine and cosine. So what we're going to start working with now is this unit circle, okay? So like I said before, let me skip down to the very bottom here, right to here. So we are eventually going to fill all of this in, okay? Which is great. It'll get you guys to practice your values and your angles and stuff. But I've also uploaded a blank, like half page, like, well, full page, one of these. So you guys can write in your values and have it sort of looming around, and you can put it up on your poster board right next to InSync, just so you don't forget the values. It's one of these things that you're going to use it so much, you're going to end up memorizing the values for them. But until then, print this out and have it looming around. Just and once we get to it, once we fill out the entire thing, you will have something at the ready, so we can refer to it over and over and over again. Okay. So back to here. So the first thing I want to do, I'm pretty sure a lot of you guys have heard of this thing, SOHCAHTOA. Okay. And that tells you that it's sort of the definition for sine, cosine, and tangent, which are the three big ones for now. But let me get into what a unit circle is. So the unit circle is a circle with a radius of 1. So this radius up to right here, this length right here is 1, just how it is right there. Okay. A unit circle is divided into 4 quadrants: the first, second, third, and fourth. Okay. And each one of those quadrants has something nice about it. Okay. When it comes to sine, cosine, and tangent. The way that sine and cosine are defined are right here. So depending on, notice what the definition states, right? Those are t's, which are angles. Does that make sense? So depending on an angle, it has an x and a y attached to it, right? So if this point right here is xy, right, the x portion is called cosine and the y portion is called sine. So still doesn't answer very much in terms of how we define sine and cosine. Specifically, so what we're doing now is this. So you guys have this radius of 1, right? How far over and how far up did you have to go to get to that point x and y, right? And that's the basis for the definition of sine and cosine, okay? They are specifically the ratio of the hypotenuse and how far vertically and how far horizontally we need to go to get to a specific point. So this is the best. I am not kidding. Think Etch-a-Sketch. So hopefully everybody remembers the Etch-a-Sketch where, let me actually bring up the picture of an Etch-a-Sketch. For those of you born past 2000. I mean, back in my day, we had Etch-a-Sketches and they were fun. Let me copy a picture of it really quick. Copy image. Okay. Actually, my picture isn't too far off. Okay. You guys remember one of these? I hope so. And if you don't, that's okay. So the idea behind this Etch-a-Sketch, right, was one of these knobs, this one, right, would be an up and down, right? And the other one was a left and right. So if you spun this one in a certain direction, it went, your little cursor, right, went either up or down, right? And then if you spun this one over here, it went left and right, right? And here's the definition behind sine and cosine. Suppose that you had a point here, right? Suppose that you had a point here, and let's say it went out to a point way out here. This thing is going to have some length r, right? There had to be a specific amount of times you had to spin this one. Actually, let me go the other way first. There had to be a specific number of spins on this one to go over to that point, right? On the x-axis, right? And then there was a specific number of spins you had to do for this point in order to get up there. Does that make sense? That right there is the definition behind sine and cosine. So then this one would be sort of like the cosine, right? And this one would be sine. Okay? And the measure that both of these are requiring, right, is for this angle theta right here. So for a specific angle, theta, right, how many times do I have to spin this one and this one together to get to my point way up here? That's the definition behind sine and cosine. Okay? You know what? You guys want to be done for today? I know it was largely uneventful for today. We got through some of it. We'll get through the rest on Wednesday. Cool?
Cool.
Okay. I'll put up the stuff for chapter 5 real soon. In the meantime, do that. Catch up on your own stuff. I'll put up some more late passes for people to get through stuff. Cool.
Yeah.
All right. I'll see everybody on Wednesday. Bye.